In this lecture, we will discuss how to write an embedded C program for 8051 to move a block of data which is stored in internal location to another internal memory location. So before going to the programming part, we'll discuss some basics of the memory organization, or very specifically the RAM organization, or we can also call it as a data memory of 8051. There are two types of RAM possible in the case of 8051, that is internal RAM and external RAM. So the internal RAM is actually 128 byte, that is 128 byte, which is addressed from 00H to 7FH. Okay, the address is represented in hexadecimal, that's why it's from 00H to 7FH. Or if you write the decimal value, corresponding decimal value, it's from 0 to 127. And in 8051, you can see one more RAM that is known as the special function register SFR. It's actually from 80H to FFH. So you can see an additional RAM 128 byte in 8051, but this SFR register or extra RAM is not used for the general purpose programming. So usually the data are stored in general purpose RAM, that is from 00H to 7FH. And if the memory is not sufficient, there is a provision to connect an external RAM, and the maximum capacity that we can connect in 8051 is 64K, and the address range is from 000H to FFFH in hexadecimal. And if you consider this internal general purpose RAM, you can see that it's represented from 00H to 7FH. So it's represented in hexadecimal. So the binary equivalent will be 8-bit value 00000 uh, 0 1 1 1 1 1 1 1. So this is equivalent to 00H, and this is equal to 7FH. So actually representing a 128 byte, we require only 7 bits, but as a standard we will use 8 bit because the SFR is from 80H to FF. So total we required 256 location. So in order to represent 256 locations, we required 8 bit. So we are using an 8-bit address to represent the internal RAM. So the maximum address ranges from 00 to FF in the case of internal, but in the case of external, it's a 16-bit value because we need to represent a 64K byte. Okay, this is all about internal RAM. And here we'll see how we can transfer a block of data which is stored in the general purpose RAM. For example, assume that some data is stored in this particular general purpose RAM. That value we need to transfer into another memory location, which is also in the internal RAM. Okay, and first we will see how we can transfer this data. So in the question, the memory locations are not specified. So we'll assume that some values. Okay, assume that the internal memory location 28 onwards we are storing the value, that is a source. Okay, uh, source location, and we need to transfer the data to another location which is 48 onwards. Okay, make sure that both addresses are within the range 00H to 7FH. Okay, so we cannot go beyond this 7FH because we are using internal RAM. This program is designed for internal RAM location, so we cannot move more than 7FH. And we'll take some random values. Assume that the memory location 20H, which is the starting location of the source, that is 20H, and the 20H holds a value FE, and from 21 it's FF, and 22 EF, and 23 DF, and CF, BF, and 26 contain F. And also the size of the block is not mentioned, so we'll assume that or we'll take an example that 6 is the array size. Okay, we need to transfer 6 data which is stored from 20H to 25 to another memory location of 40 to 45. Okay, we don't want to consider the value which is stored at 26 because we need to transfer only 6 data. Okay, so after the execution we need to store the content of 20H to FE. Okay, and after that we need to transfer the data which is stored in 21H to 41H. That is FF should be loaded into 41H. And if you do this particular operation, so we know the address, that is 20H. We need to transfer the data of 20H into 40H. Similarly, next operation should be 21H. The content of 21H should be transferred to 41H. Similarly, you can continue. And in this particular example, the array size is 6, so it's an easy job. But when the array size is very high, it becomes very difficult to write a lengthy code. So instead of this direct addressing, we need to consider an indirect addressing concept, either in assembly language programming or in embedded C programming. So in this particular lecture, we will discuss only embedded C programming. So indirect addressing concept we can implement by using a pointer. Okay. So by using the pointer concept, we can implement this indirect addressing, or directly you can mark the address. Okay. So for that, so before writing the program, we will discuss the algorithm. Okay. So here the 20H is actually the source address, or the starting address of the source block, and 40H is the destination address. Okay, destination starting address. And we need to declare some variables to point this destination. So we'll declare some destination variable, and we'll also discuss declare a source pointer in order to point this 20 and 40. Okay, and similarly, to perform the operation 6 times, we need some loop control variable. So we'll define one variable called I and another variable count. And one thing is important, that here we don't require a bigger pointer or a bigger source address pointer, because in 8051 the address capacity or the address range is, internal RAM address ranges from 00 to 7F. So maximum we require 1 byte. So we need to define a pointer variable with size is equal to maximum 8 bit, and also the loop variable and count variable. Now, in this particular example, we can declare the destination address pointer by address 40H and source with 20H. And you can also assign the loop variable I is equal to 0 and the count register is equal to 6. Okay, and now we can start the operation. So we got some variables, and now we need to read the content of 20H. So 20H is actually loaded into the source pointer. Okay, that is SRC, and we need to take the content of SRC. So we'll write like this, and the content of SRC, so this is a read operation. So we'll read the content of location pointed by the source pointer, that is SRC, and we will store the value into destination point. So destination is actually indicated by desti. So we will store the content of SRC into destination. So SRC means 20. So the content of 20 is moved to the location pointed by desti, that is 40H. Okay, that's the first operation. So after this particular operation, actually we need to change the SRC content. So now we need to change the SRC content to 21. So for that we can perform SRC plus 1. And similarly, the destination should be changed to destination plus 1. And after that, we need to change the loop control. Okay. So we completed one operation. So I can increment this I plus 1. Okay. After this operation, we need to check. So here you can see some operations. So this is a read operation, and after that we can store the value, and we can increment the source pointer. You can increment the decrement. Sorry, we can increment the destination address pointer. After that we can increment the count value. After increment the count value, we can check whether this count value is less than 6, because we need to perform only 6 operations. So we are starting from 0 onwards. So after this operation, the count value is incremented to 1. So now we need to verify that whether the count value is less than 6. If it is less than 6, again we need to go to step 5. Okay. In step 5, again you can see that we will perform the content of source. We will move to, so now the source address is equal to 21. So instead of 20, the content is 21 and destination address is indicated by 41, because we are performing the source is equal to source plus 1 and destination is equal to destination plus 1. So now the content of source is 21 and the destination is 41. Now we'll move the content of 21 into the address pointed by destination, that is 41. Okay. Similarly, we will perform this operation 6 times and we will exit from this particular program and we can stop the program. So this is a basic algorithm. And now I will give you some introduction about the data types that are commonly used in embedded C program. This is a commonly used data types in embedded C program. Okay. Some data types are not available in standard C program. This special data types that we are used for 8051 embedded C program. So the S bit SFR are new to this C programming, embedded C program. No, it's not available in standard C compiler. Okay. And here we can see that we are using a character and unsigned character. See, usually to store this integer values in C program, we will use the keyword data type int. But in this particular microcontroller, we will not use, we can use int, but we don't require int actually, because the maximum data size is 8-bit. So we will limit our discussion to 8-bit. So in order to store an 8-bit value, the character data type is sufficient. So a character data type can store 8-bit, and also we will use unsigned, because we are considering only positive value. Okay. And one more point here, the data and the address. Okay. If you take the RAM, internal RAM 128 byte, the address is from 00H to 7FH. Total there is 128 location, and each location can hold 8-bit. Okay. So store the data, we require only a data type which can hold 8-bit data, and also to point the address. Again, we require only 8-bit. So the character or unsigned character is sufficient for to perform this particular operation. So we don't want int or unsigned int. So we will limit our discussion by using this unsigned character. Okay. And by using this character, you can address 0 to 250, or it can hold a value from 0 to 255. So the maximum is only up to 7F. Okay. So the maximum address value is 127. So this particular data type is sufficient. Now another point is about the pointer. Okay. Before discussing the pointer, I will give you just an idea about the memory. So when you discuss about a memory in a microcontroller, it's actually a location which can hold 8-bit value, and this particular location is addressed by another number. That number, for example, in this particular case, assume that this is a address or the value which is used to represent the location, and that value is usually we'll call it as an address of the memory location, and it can hold some value. For example, this memory location holds a value 33H. So this is the data. And in 8051, internal RAM can hold 8-bit value, and the address is also 7-bit byte. So we'll take it as an 8-bit. Okay, maximum we require 8-bit. And some memory location we can also represent it by a variable name. For example, this location maybe I can represent by using some name also. Okay. In This is a normal variable concept. Now I will discuss the pointer concept. So this memory location, for example, I can represent by the variable I. Okay, assume that this location I can also represent by using the variable I. Now I will declare another variable which is known as a pointer. So pointer means it can hold actually data, but that value is actually address of other memory location. Okay, so here I can declare or this memory location. For example, assume that this is 27h. Okay, 27h, and this 27 is actually used to store the address of some other location. So for that I can declare a variable. For example, here unsigned character, uh, let it be x. Okay, star x means x hold the address of a character type data type. Okay, that's the meaning of a pointer. Means it will declare some memory location. For example, it is 27h is represented as x, and this x or 27h holds some value, and that value is actually address of some other memory location. So in this particular case, if you write x is equal to 20h, means here it will be 20h. So here you can see that this unsigned character star x means asterisk x or pointer x, and assume that x holds 20h, means x holds some value, and this data is actually the address of some other memory location. Okay, either you can write 20h or I can write like this: x is equal to address of I. Okay, so this ampersand symbol I can use. Instead of this x is equal to 20, I can write like this: x is equal to ampersand of I, means x holds the address of the variable I. Okay, so I means 20h. So the 20h, the value 20h is loaded into x. And in pointers, when you use star x, means it's actually pointing the content of x. Okay, uh, content of x means x is pointing some location. So x is holding 20, and here we can indicate that the content of 20. Okay, so x is holding some value, that is 20h, and in 20 we can see some value. So if you use star x or asterisk x, it's actually indicating the value 30h, sorry, 33, because in 20h you can see the value 33h. Okay, this is about the pointer concept, and now we'll move to the program. So in this particular program, we can see that we need to declare some variable, two variables for pointers, destination and source, and other two variables are normal variable for loop control and count. So here you can see the first statement. Before starting the program, you need to write the statement hash include rich 51.h. So this is a standard keyword that we need to use in most of the embedded C program compiler, and this is not used in normal C compiler. So this hash include rich 51.h is an header file which is used to program the 8051 microcontroller. And here you can see our main program. Main program starts here. Okay, and the first line you can see that it's unsigned char star destination comma star source src I comma count. So as mentioned in the algorithm, we need to declare some variables, two pointer variables. So here you can see two pointer variable, destination and src. Okay, so I'll call it as destination is actually dest t and src, and two other variable I and count. Okay, so here you can see that this dest will hold the address of a character type variable, and src is also hold the address of a character type variable, and I and count are unsigned character type. Okay, that's the meaning. So we declared some value. Now we can assign the standard value. In the example, we already mentioned that destination address starts from 40h. So the 40h hexadecimal value will be represented in C program, embedded C program like this: 0x40. Okay, and the address 20h, hexadecimal value 20h will we represent like this 0x20. Okay. After that, you need to assign the count value. In this particular example, the count value is 6, so count register is equal to 6. The destination and source are pointers, so we are loading this destination and source by using some address. In this particular example, we know the starting address of source and destination, so we can directly directly we can move the value into this destination and source pointer. Okay. After this, we need to perform the data transfer operation. That is, we need to uh, transfer the value from 20h to destination address 40h. So when you use the pointer concept, you need to write like this. This will be the statement. SRC is actually contain the value 20h. So we need to access the content of 20h. So we'll write like this, star within the bracket SRC, okay, which is equal to destination. Okay, so this is the exact representation to transfer the value in 20h to 40h. Okay, so the content of 20h will be moved to 40h. So this statement we will write in a C program like this, star src is or star destination is equal to star, the operation will be like this. Okay, and here you can see the statement. Either you can write like this, or you can write this pointer array in another format. For example, the source starting from 20h onwards, next value is 21 and 22, 23, 24 and 25. Okay, either you can write the program by using the pointer notation, or I can use the array also. Okay, because when you define any array, for example, if you are define a of 5, okay, means this is an array, and a is actually representing the starting address of the array. And in this case, we know that starting address of this block is src, and the destination block starting with desti. So we can consider this as a block of data. So instead of writing this pointer concept, very simply you can write like this. The first element, for assume that this is a source, and this src means it will point to 20. And the first element we can represent src 0, and another one src 1 and src 2. Similarly, I can represent each value. Okay, so instead of writing the pointer notation, I can also use the array notation. Similarly, the memory location from 40h onwards, I can address, or we can represent by using the array concept. So the 40h, 41, 42. The 40 I can represent by using destination, and desti within the bracket 0 means it will point to the first location, and destination 1 is actually pointing to 41. Desti means the 40 plus 0 means the first location, 41 means the next location, and similarly. Okay, so either you can use this particular notation if you are comfortable with the pointer notations, or I can use the array concept. So for the simplicity, I am using the array concept. So you can see that src I is assigned to destination I. And for the controlling loop, we are using a for loop. Initially, we will assign I is equal to 0. Okay. After that, we will assign the first location value, that is 20h, content of 20h is assigned to that src 0. I can assign to destination 0. Okay. After performing this, this for loop contain only one instruction. After this, again, it will go to this I plus plus 1. So it will increment I. Now I is equal to 1. Initially, I is equal to 0. The initial value of I is equal to 0. Now I is equal to 1. Okay. So next operation will be src 1 will be assigned to destination 1. That is the content of 21. Okay, 21 contains some value. That value is moved to 41. That is the destination 1. Similarly, it will continue. I will be incremented. When I is less than 6, it will continue the operation. When it reaches to 6, when count value is less than, when it is equal to 6, it will exit this particular loop and it will move to this particular instruction. This while one is actually, we know that while some condition is given, usually this is a notation, and there is no statement means, and also the condition is given 1 means the condition is always true. Okay, if you write while 1 means the condition is always true, so it will execute this while loop indefinitely. Okay, this is an infinite loop while 1. So usually we'll write this particular statement in microcontroller 8051 programming if you are not performing the operation continuously. Okay, so in some cases we will repeat the entire process. At that time we will not write this. Again condition will move to some other location. But if you are performing this operation only at once, we will write this statement while 1. So the program control will stuck at this particular point. It indefinitely it will execute this particular instruction. So while 1. Okay, this is all about the programming. Now we'll see how we can execute this program or we can debug this program on a compiler. Okay, so now we'll see the C compiler, embedded C compiler write. Okay, so this is the write 7 compiler. Here you can see already I loaded this program. It is written in C. So the previous program is written in this particular editor window. After performing the build operation, so build operation I can perform by using the build project. Okay, so once you, after the compilation build successful, you can move to debug, and debug you can start debug. So this is the debug window. So make sure that you are performing this debugging operation in debug. So in the debug window, you can see some buttons here. This is start button and step into button. So if you want to continuously run the program and we need to see the final output, you can press this run button. But in most of the cases, we will perform the step into instruction. So here you can see the step into. So also we need the data transfer we need to verify. So for that we can take the data view. On the left side, you can see the memory view, and from this memory we can choose the data view window. So here you can see the data view window. And before executing the program, we need to assign some values in the source location. Here, if you observe the values 0, 0, this is actually data view and data memory RAM. The first location is 0, 0, and the 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7. And the next location is 0, 8, etc. And this is your source 20H. Okay, initially all these values are 0. So I can put some random values here, 5. Any some random values you can give to. So simply double click on that particular portion and enter the values. So you can hold some values. Okay, assume that 20H holds 5, 21, 3, and next location 2, 7, 9, 4, 5, 8. Okay. And you can observe after the execution the content of 40H. 40, initially all these location holds 0. Now we can start the execution, and when you start the execution, either you can use run button or you can press step into. Now we'll check by using step into. So when you press this, the first instruction, it will execute. The destination is equal to source. So after execution of this particular instruction, we can see what's the change at this particular memory location. So I think you can view this location. 40H initially holds 0 and 20H is 5. So after the execution of instruction, you can see that 40H is loaded with 5 because 20H is holding 5. And there is a count variable that is I. You can also see that variable by simply typing that key. So if you press I, you can see a blue highlighted portion. So the memory location 08 is actually assigned the variable I. So I already mentioned each memory location I can represent by using an address or by using name. So here this name I is allocated for the memory location 8. Okay. Now yeah, and also you can see that this location, the destination is actually 40 and source is actually 20. That value is also stored in this particular address location. So these two are the pointers, desti and source. Okay. Now we'll execute the next step. So after the execution of next instruction, you can see that 3 will be here. Okay. And I value is 1. And after executing, you can see 2, 7, okay, 9. And after this execution, you can see that there is 1, 2, 3, 4, 5 values are loaded. We need to load one more value, that is 4. So after that, the condition violates because it's 5. If you increment this again, it's 6. So condition violates and the program control goes to the while loop. And after this, there's no change in value because we already transferred 6 values. Okay. Similarly, you can reset this program and again you can try some other random values. And if you again press this statement, step into, you can see that program is executing. That's why there is some cycles. You can see the time is incrementing like this, but there is no change in the data memory view. It's exactly the previous one. Okay. So this is all about, and also you can see, if you look at this assembly view, you can see the assembly language program which is written by this compiler. Actually, we will write the program in C program, but the compiler or this debugger will automatically write some assembly language program corresponds to the C program. See, for I is equal to 0 to I less than count I plus 1, instead of this C program in the assembly language, you can see that some instructions are written. INC1, sorry, INCI, SJump 70H, etc. Okay. Instead of this while one, they are writing some other instruction, SJump 97H. So the program will definitely infinitely loop here in this particular region. If you look at the initial portion, similarly, you can see some data transfer instruction and all. Okay. So if you write the program in embedded C, the compiler will automatically convert that program into assembly, then finally into binary. Okay. So this is all about the internal data transfer program. Okay. You can verify by using data view, and you can sustain some value, and you can check whether the values are values are transferred from 20H to 40H. Okay, thank you.